The coefficient of static friction between a 3 kg crate resting on a ramp inclined at a 35-degree angle is 0.3. What must be the minimum force that must be applied to the crate perpendicular to the incline to prevent the crate from sliding down the incline? So we have a ramp. Okay, so let's say that this is the horizontal, and there is a ramp inclined at a 35-degree angle. This is 35 degrees. And then there is a crate that is resting on the ramp. The mass of that crate is 3 kilograms. And so we are asked to find the minimum force that must be applied to the crate that is perpendicular to the incline to prevent the crate from sliding down. So there is a force F perpendicular to the incline, okay, that is applied to prevent it from sliding down. So that's the question. What is that force? So looking at this, what are the forces involved? What are the forces that are perpendicular to the ramp and the forces that are perpendicular to the ramp and that are parallel to the ramp? So, of course, we have the weight. The weight is directed downward. Let's make that Fw. So we have the component of the weight that is parallel to the ramp, which is Fw sine of 35 degrees. And we have the component of the weight that is perpendicular to the ramp. That's Fw cosine of 35 degrees. Why? Because this is 35 degrees here. Okay, and then we have the frictional force that is directed upward. It's not moving, so that's static friction. And we have the normal force that is directed, applied by the ramp to the crate, that is Fn. So we're going to make a balance of all those forces. So let's consider first the forces parallel to the ramp. For the forces parallel to the ramp, it's not moving. Net force is 0. So net force is equal to the upward forces Fs, okay, minus the vertical component of the weight, which is Fw sine of 35 degrees. Again, this is equal to 0. So 0 equals Fs minus Fw sine of 35 degrees. So Fs equals Fw sine of 35 degrees, but then Fs is mu s Fn, that's Fw sine of 35 degrees So the normal force is equal to Fw sine of 35 degrees over the coefficient of static friction, μs. And then we consider the forces perpendicular to the ramp. So the net force is equal to all the upward forces pasaka, and that is only the net force, Fn. And all the downward forces, so what are the paubos nga forces? We have the applied force, F, minus pagyud, minus this horizontal component of the weight, Fw cosine of 35 degrees. But then this net force is 0. So our applied force F, which is what we are looking for, is equal to the net force minus Fw cosine of 35 degrees. But since the net force is equal to Fw sine of 35 degrees over μs, we substitute that Fw cosine of 35 degrees. So we factor out the weight, so that's sine of 35 degrees over μs minus cosine of 35 degrees. Then Fw is the mass of the crate times the acceleration due to gravity, sine of 35 degrees over μs minus cosine of 35 degrees. So our applied force is equal to the mass, which is 3 kilograms, times the acceleration due to gravity, 9.81 meters per second squared, times sine of 35 degrees divided by the coefficient of static friction, which is given in the problem, that's 0.3 minus cosine of 35 degrees. So the applied force is equal to, computing 0.3 times 9.81 times sine 35 over 0.3 minus cosine of 35, that would give us a force of 3 times 9.81 times sine 35 over 0.3 minus cosine 35. The force that must be applied is 32.1602 newtons, so that the crate will not slide down the ramp.